In this video, I take you into the world of relative motion. We are back into reference frame. That's a concept that I talked about you in one of the earlier videos. Let's go to a familiar, question, which we would have done in 10th standard, right? Where there was a train A and there was a train B. Train A was traveling at 60 km per hour and train B is traveling at 30 km per hour. And here you are standing stationary on the ground at a point P. What is the velocity with respect to you? In your reference frame, train A was moving at 60 km per hour. How fast was but what if you were sitting in train B? How fast would train A be traveling, right? Or what would be the velocity of A with respect to B? And the way we used to solve it is, the velocity of A with respect to B would be equal to the velocity of A minus the velocity of B, that is equal to 60 minus 30, and that's equal to 30 km per hour, right? So for somebody sitting in B, A would be moving at 30 km per hour in his reference frame. However, with reference frame to the ground, A is moving with 60 km per hour. I just want to put this in perspective and say that when you say velocity of A with respect to B, don't forget what you're really doing is you're taking the velocity of A with respect to the ground, and from that you subtract the velocity of B with respect to the ground, right? Now, in relative velocity also, there is direction. It's a vector. There is positive and there is minus, right? So in this, what we really mean here, if B was stationary, he sees A moving in the forward direction. But now let's reverse the question and ask, what would be the velocity of B with respect to A? For somebody sitting in A and he looks back at the train A, because A is traveling faster, sitting in A, you look back at B, what would be the relative velocity, right? Now we look at the velocity of B with respect to A, and what you find would be the velocity of B with respect to the ground minus B, velocity of A with respect to the ground, and this would be equal to minus 30 km per hour. The sign has changed. Why has the sign changed? Because if you were stationary in A and you look at B, B is moving in that direction. You feel, or in your reference frame, B is going backward. So it's negative. Whereas B is looking at you, you're going forward. So the velocity, the direction of relative velocity is positive. Whereas for the guy P, both of them are positive because both are going in this direction. I hope this is clear because this is a very fundamental concept before we move into the next slightly more advanced concept. Or rather, let me say, I'm just putting it in perspective. So we have a person at point A, he's stationary. We have a car B, which is moving at a constant velocity. And there's a car C, or let's say car P, right, which is also moving at a constant velocity. At any point of time, if we take the position, so this is stationary, this is moving at a constant velocity in this direction, this is moving at a constant velocity in this direction, we are taking the forward as positive and backward as negative, right? So at any point of time, if we were to measure the position, we would say the position of P with respect to A is equal to the position of P with respect to B plus the position of B with respect to A. Agree? P with respect to B plus B with respect to A is equal to the position of P with respect to A on a coordinate axis system. Now, if you were to differentiate this, you would say the velocity of P with respect to A is equal to the velocity of P with respect to B is the velocity of B with respect to A by differentiating this, right? Now this is an important equation or an important information of the way of seeing things, because this is what so many times we use to solve problems of relative motion, okay? So keep this in mind that V of PA will be equal to V of PB plus V of BA.